All right, so in this lesson we're going to be learning how to build a website that can control an Arduino LED matrix. I've got my LED matrix right here. So the way this works is you click connect, and then you click this pair button, then you click connect right here, and now I'm connected. So when I push one of these buttons, you can see the LED light up here. So this allows me to draw on the LED matrix. So I can draw a little happy face. I don't know, just making something up. And yeah, so that's my little happy face right here. You can kind of see all sorts of fun things you can draw with this. So we'll be learning how to build this. This is the message that we're sending from the web browser to the Arduino. And each of these zeros and ones represent an LED that's being turned on or off. So yeah, so we'll be learning how to build this and how to get all this working. So let me know what you think, and I will catch you later. All right, so in this section, we're going to be setting up our svelte project for controlling our Arduino LED matrix. So let's get started. First thing I'm going to do is install svelte. I already have the project folder I want open, so I'm just going to do the dot to clone it in there. Then I'm going to do a clear. I'm going to do npm install, and then I'm going to go to Google Fonts. So it's fonts.google, and let's use a fun font for this. That looks cool. Let's use the Rancher font. So 400 sounds good to me. So let's copy that. And what we'll do is we'll go into our public index.html file and paste that font in. And while we're here, let's call this Arduino LED Matrix. And let's make all these links relative. So we're going to need this for GitHub pages. And let's also go into our global CSS, delete everything, and do body, font family, and we'll just copy this. And so this should have the font we want. So that's good. The other thing we're going to need to do is go into our source folder, and we're going to delete everything in our app.svelte file. So we'll delete that. We don't need to pass any props into our app component, so we'll delete that. And I think that should do it. Okay, we just want to test this out though, so I'll do an h1 test, and I'm going to clear and then do npm run dev and just make sure everything's working. And that looks good. All right, so in the next section we'll start building the app. In this section, we're going to be creating our user interface for the LED project, and we're going to use a little bit of JavaScript to do this. So we're going to need help from a library called Lodash, and we're going to need this range function. And what range does is it generates an array of numbers. So we're going to need that, and we're also going to get some practice with map as well. So let's get that installed. And we got it installed. We'll clear, and the first thing we'll do is we'll add our script tag. I'll use Emmet to do that, and then we're going to create an array of LEDs. So oops, I don't know why I did that, but that's okay. Oh, before we create the array of LEDs, we need to import that library. So usually the way you import Lodash is you use this underscore. So that's the most common way. Could probably also, if we wanted to be like super picky, we could do something like that, but I like the underscore better, even though it's probably less efficient as far as code goes. Then we want range, and let's see, we want to create an array between 0 and 9, 0 and 8, so that'll create 0 through 7 because this is exclusive, it's not inclusive. The 8 isn't inclusive. Then we want to map that, so because we want to create an array of arrays. So we'll use another range function to do the same thing, 0 to 8. but we don't want an array of numbers. What we actually want is an array of true or false values, or on and off values. So we'll just set all these, everything inside the array to false. And I'm going to turn on the server and console.log that just so you can see what that looks like. So, because I know this is a mouthful. PM run dev. Let's get that running. And let's go. And if we inspect element and we go to our console, you can see we have an array of 8 elements. And yep, so you can see they're all false. So that basically represents our LED grid. Okay. So the next thing we need to do is we need to loop through all our LEDs and use that grid to basically represent what we need to generate on screen. So what I'm going to do is I'm going to say, use an each block as row. Is it as row? Yeah, I think it is. Okay. And in between here, there'll be a section with a class of row. And then we'll have another each block. So we'll say each, oops, if I can type, got fat hands today. Each row as LED. And this will do a circle. And this will have toggle, this will toggle a class, this LED will toggle a class on or off. So we'll say, let's see, class on. So if LED is true, the on class will appear. The other thing we need to do is we need to attach an argument to this. So we're actually going to need the indexes. So we'll say row index, and we'll say column index. Okay. So this will tell us which LED is being put in. So we're going to do an on click, and we'll say on toggle LED, and we'll say row index and column index, and we'll make it official by doing that. So it's looking good. The only problem is that we don't have our on toggle LED function, so let's create that. So function on toggle LED, it takes in a row and a column. And all we need to do here is we just need to say LEDs row column equals does not equal LEDs row column. Now this won't work because we're not setting it to a new LED. So you have to remember that everything is based on the equal sign. So in other words, if you can't set a single element in the array, you have to set the whole array to a new one. So what you can do is you can just use the spread operator and just copy everything to the new array. So that's the cheap way of doing it. We need to test this, so let's do that. And to do that, we're going to need to write some. Let me move this down. We're going to need to write some JavaScript, or I mean some CSS. So let's just create a few styles just to test this. So we'll say, and I forgot to, forgetting a little bit today here, sorry guys, to put all this in between our main. Okay, so we're going to style our main first. It'll have a width of 500 pixels, a height of 560 pixels, and a margin of 10 pixels auto. So auto will center it. And just so we can see it, we'll do a border solid gray 1 pixel. Let's see what that looks like. Looking good. And then we'll do a section dot row. And we're going to do a display flex because we want each circle to take up the same amount. And I think that's it for that one. We'll see. And then a div.circle. And we'll do a width of 50 pixels, a height of 50 pixels, a border radius of 50%, a margin of 5 pixels all around, and a border of solid gray 1 pixel. Let's see what that looks like. Okay, that's looking good. And then we will do we'll also do a background color of that. Okay, and then I want the board itself to be black, so I'm going to do a color, background color of, and I experimented with this a little bit, to be honest with you, of that. So that looks good to me. And then if it's on, so div dot on, we'll do a border, do a background color of something red, so AA 000. So that's pretty red. And let's see if this works. It's looking good. So now we can toggle them on and off. So that's really good. Looks like I made this a little too big, which is kind of funny. I don't know. So that's easy to fix. So let's try 540 maybe. Maybe 500. Maybe it is 500. Yeah, 500 looks good. Okay, so we got that. Let's also, while we're here, do our H1, text align center, and we'll call this LED Matrix Arduino. And that looks a lot better. Okay. So, yeah, so I think that's pretty good. That's really good. Okay, so our next video, in the next section, we'll make the thing to, we'll basically generate the code to generate what we're going to send to the Arduino to turn on the LED matrix. So I will catch you then. Okay, so in this next section, we're going to create and display the message to show what we're going to send from the web browser to the Arduino. So let's get started. I'm going to open up my app.svelte file, and the first thing I'm going to do is create an H2 and call this Arduino message. And we'll also add a style here as well so that it's centered. So that looks good. Next thing we'll do is we'll create a section to display our message, or what we're going to send, and I'll call it, we'll just call it message. And we'll have a reactive variable called Arduino message. We're getting an error here because we haven't created it, so let's do that. So the way you create a reactive variable is with this $: syntax. And now we're going to say LEDs dot, and let's see, reduce. And reduce takes in an accumulator. You got to be careful, because sometimes visual code will autocomplete for you, and a value. So this is the total, this is the final result, the accumulator that's being accumulated over time, and the value is the current value of the LED that we're reducing. And we just created an anonymous function, and the second argument is the starting value. So this is the value we're going to start off with. So this is going to be an empty string to start off, and then we are going to return the accumulator plus the value, which is an array of true or false. So we're going to map that. And we'll just call this, we'll just call this L, just to keep things simple. So if L, which is our current LED, is true, we're going to say it's 1. Otherwise, we're going to say it's 0. And then we're going to join with this. And then we're going to add another colon. But I'll show you what happens when we don't, just so you can see why we're doing it. So you can see when we don't do that, we get these 2 zeros right here. So the rows themselves don't get separated. So we do have to add that extra colon. And I'm going to make this a little bit bigger so you can see. But you can see there's an extra one at the end. So to get rid of that, we can use slice, which will create a new array. Oops. Slice. And we can say -1. And that should just get rid of it. Oops, I think we have to say 0, -1. So we want 0 to -1. So slice will just take off, that'll just take off the last character of the array. So now when we do this, you can see it updates right here. Or a simpler one would be this, updates right there. So that looks pretty good. Let's format this a little bit more. So I'm going to say section protocol. I'm just going to make this look a little nicer. And we're going to say width 500 pixels. We'll say word wrap, break word. We'll say border solid gray 1 pixel. Let's see how that looks. Oops, it's not protocol. That's my fault. It's message. So you guys are probably wondering what the heck I was typing. So it looks okay. It'd be nice if we centered it and gave it some padding. So we'll give it a padding of 5 pixels. And let's center. So we'll do margin. We'll do 10 pixels auto. So 10 pixels top and bottom, and auto left and right. And that looks pretty good. So this is going to come in handy because we'll be able just to copy and paste this in. And there's one thing I'm forgetting, and that's that we're going to need a character at the end of this to represent the, basically to represent the delimiter character. So the Arduino knows when to stop reading or stop receiving a message. So our delimiter character is going to be and I'm just making this up right now, an @ sign. So you can use whatever you want. I like @ just because I think it looks good. So with that, we have our message ready to go. And we're ready to start attacking the Arduino part of the problem. So I have a wiring of the Arduino to the LED matrix. I'll have this embedded in my website along with pictures of me wiring it up. VCC, this VCC pin, and when I say pin, I mean this piece of metal, goes to 5V. GND goes to GND on the Arduino. DIN, which is this orange wire, goes to 12. CS goes to 10. And CLK goes to 11. And like I said, I'll have pictures of this, and I'll insert a picture in here as well of the final wiring and how it should look like. But yeah, so if you're having any problems, go to my website and also post questions in the video. So in the next section, we'll start coding this up and getting everything rolling. So I'll see you then. Video, we're going to install our LED matrix. So let's go ahead and do that. Click on this code button and click on download zip. I've already downloaded it. And then what you're going to want to do is you're going to want to open up your Arduino IDE. So I've got mine open right here. And you're going to want to go to Sketch, include library, add zip. And then you're going to want to go to Downloads, and you're going to want to download the zip right here. So if I click Choose, you'll notice I get an error which says LED, a library named LED Control Master already exists. So that looks good. So I've got mine installed. Then go to Arduino file, I should say, new. And we're going to create a new LED Arduino project, which is right here. Make this a little bit bigger. And let's get started. So the first thing we're going to do is we're going to include, well, the first thing we're going to do is we're going to save. We just need to get in the habit of doing that. And I'm going to call this test because it's in a certain folder already. So we'll call this LED matrix test. And in this, with this test code, we're just going to test and see how this library works relative to our LED matrix. So the first thing we'll do is we'll include the library into our code. So let me move some things out of the way so I can type. So we're going to say include LED control dot h, and then we're going to say LED control, and then this is a special variable called an object. So you do the type of the object first, and then what the variable name is, and then we're going to set that equal to the constructor, which is also the type of the object. And then this takes in a few different variables: 12, 11, 10, and 1. So let's put the important arguments, which are basically the things that we're passing into the constructor, up here. So 12 is for the data pin, 11 is for the CLK pin, and 10 is for the CS pin. And all these pins are labeled on the LED matrix. The important thing to note, is just which pin goes where, and just make sure that you're passing everything in the right order. So now that you got that, we're going to go to our setup library, and we're going to say matrix.shutdown, and we're going to say 0 false. 0 false will basically wake up the LED matrix. Then we're going to do another one called set intensity, and this one you can play around with. This one's for setting the brightness of the LEDs. So this sets the brightness of the LEDs, and then we'll say matrix dot clear display, and this will clear everything. So what we want to do here is we want to see what we're printing out. But before we do that, one thing I forgot to do is we also want to have some serial logging, just so we can see what's going on with the serial. So we can print out messages. So we're going to say serial.begin, and I'm going to pass a baud rate, and this is basically the number of bits per second that will go through the USB wire. So that's our baud rate, and then we're going to say serial.set timeout, and I'm going to say 10 milliseconds. So this is how long the serial monitor will wait for a message to come in. Okay, that looks good. So now that we have that, we're going to create a for loop, and we're just going to loop through. We're just going to loop through a row or a column of the LED matrix. So we know there's 8 total, and we're going to say plus equals I, and we're going to say matrix dot set LED 0 I 0 true. So 0 just stands for address. So this would be if we had more than one. We only have one. I is either a row or a column, and 0 is either a row or a column, depending on how we positioned our LED matrix. And then true means turn on, or false would be to turn off. So true or false controls whether the LED is on or off. And we're going to say a delay of 2000. And we're also going to print here. There's a serial.print ln. And we're going to print basically this. And we're going to say plus, and we have to wrap this in we have to turn this I into a string. Right now it's a number. so we can create the rest of our string. So we're going to print basically what we're sending to the Arduino to make this happen. Oops, looks like I copied the wrong thing. So we got our I part, we just need to copy this part and then close everything out. And then we'll turn it off and wait another second. So I'm going to say false, and then I'll say delay 1000. Okay, so now that we have that, let's go to Tools and make sure that Arduino board is selected. So Tools, Port, and we're going to upload this. So that'll take a second. And then I'm going to have a separate video of this going on, but let's look at our serial monitor. And let me move this over here. I'm going to clear this out because we got some nonsense, and I'm going to restart the Arduino as well, just so we can see it in its full form. So it looks like this is pretty interesting. The first argument is the column, and for us, and the second argument is the row. And what's also interesting is that the 0th row is at the bottom, and the first row is at the top, and we have ours the opposite. So our first row in our LED matrix on the website is at the top. So our 0th row would be at the top, and our other row would be at the bottom. So we need to reverse that when we send it. And that's pretty good. That's going to be pretty easy to do, but we also need to keep the order of the columns, because the order of the columns are right, because it's going in the correct way. So that's not going to be too bad to do. So we'll do that in the so we'll go back to the website, and there's also something I wanted to do to the website as well. So we'll be back in the website in the next section, fixing that and fixing some one minor CSS thing. So we've got a minor thing to fix, so we'll do that really quick. And that minor CSS fix is basically we want the cursor to look like a pointer. So that's really easy to do. So we're going to go back to our app.svelte, we're going to go to our CSS, and we just need to add cursor pointer. And that should fix that. So now when I hover over it, it looks like I can click on it, which is really good. The other thing we want to do is we want to take what we're doing to our Arduino message, and before we reduce it into a string, we want to reverse it. So this should just reverse the rows. So in other words, the top row right here should go probably like right around here. So if we go 0, 1, 2, 3, 4, 5, 6, 7. So this right here should become 1 instead of the other way around. So what we would do to do that is pretty simple. We would just do reverse, if I can spell that right, reverse. And I think that should do it. Let's see. So now if I do click on this, ooh, that actually changed the LED, so that's not good. So what we can do to get around that is we can actually just copy it to a new array, and that way it won't do that. So if I click this, that goes there, and then this becomes, yeah, so basically just to make it easy to see, you can see right here, this is now the top row. So it's basically matching what the Arduino thinks. So this is now, yeah, so this is now row 0, 1, 2, 3. But yeah, the Arduino still thinks that it's going left to right. So that's basically the fix, is that we have to copy it into a new array, and then we have to reverse it reduce it, and yep, do all that other stuff. So that looks really good. So I'm going to go ahead and save this to a new branch, and then in the next section we'll go back to our Arduino code and get that working. So I'll catch you then. We're going to get the serial monitor to basically send a message to the Arduino that will control which LEDs are on or off. Let's just go over this. We'll just make some notes for this really quick. This is the baud rate, which is the number of zeros and ones through the USB per second. And then this is how long in milliseconds the Arduino will wait for a message. And this, it will compile without this, but this is so important. If you don't, you're asking for trouble basically if you don't do this. Okay, so now that I've given my set timeout warning, we can get started. So the first thing we're going to do is we're going to create a variable called, we'll call this message. It's not super original. We'll say, we'll use the read until string, and this takes in a character, and the character that we want to read until is the @ sign. I think it's read string until. Is it read string until? Yeah, it's read string until. So the highlighting is right. So now that we have that, then we want to do message.trim, and that will just remove any extra white space. So if we get something like ... and then add, it'll just take it and remove all that white space, any white space in front. And then what we want to say is if message.length is equals 0. So if there's nothing there, we just want to return. Okay, so now if we have a message, we're going to need to process it. So I'm going to go to Google. Give me 1 second. And we're going to go to Google, and I need to find Arduino parse string. And there's a famous post right here, I think. Let's see, is it here? There's no, it's not here. It's somewhere, but it's right here. Yep, it's right here. So I'll have a link to this. Basically, you want to copy this function in. And the way it works is it takes in your whole string, your separating character, which for us would be a colon, because each of these bits are separated by a colon, and the one that we want. And everything here is 0 base. And if it doesn't find anything, it'll just return an empty string. So we're going to copy this. And we're going to go back to our Arduino code. And we're going to paste this right above the setup. Okay. So now what we can do is we can say, we can do this. We can do 2 for loops. So this will be a lot. So we'll say int row equals 0, row less than 8, because we know there's 8 total, row plus equals 1. And we can say int call equals 0, row or call less than 8, call plus equals 1. Woo, so 2 for loops. A little scary. So now what we're going to do is we're going to get the row and the column. So what we can do is we can say, so what we can do is we can say bool is on. We can say get value, and we're going to put in our message because that's our string, our separating character, which is our colon, And then we want the index, which will be row times 8 plus column. And if that equals 1, it's on. So now what we can do is we can copy this right here. And we can say call row is on. And I'm going to silence this by commenting it out. And believe it or not, this should do it. So I'm going to save as. This will be our hopefully our final Arduino. So LED matrix final. And let's upload. And it looks like it uploaded. So I'm going to make this a little bit smaller. And we're going to go back to our Arduino website. And I'm going to position these like so. Oops, looks like you can't. Can you do half? That's weird. Okay, so it's not letting me do that. That's fine, because we only need to, we'll just do it manually. No reason to worry too much about this stuff. Oops. Hopefully I didn't do too much damage. Oh, that's okay. So now let's go to our serial monitor, which is right here. And I'll make this a little bit smaller. And we're just going to paste in that. So I'm going to copy this whole string. And I'm going to paste it in. And I'm going to send. And let's see what I got. And the top one did light up. So I'll have a picture of that as well. So I'll move this up here so you can see it a little better. So if I want, so I'm going to try to create a happy face with this. So we'll do that really quick. Make sure that we're getting that happy face in. So this string should equal a happy face. So it should look like that. So I'm going to copy that. Oops, paste that in. I don't know if I pasted in the right one, so I'm going to make sure I really copy it. So Command or Control C, Command or Control V. I'm going to send, and that is a happy face. So I'll have a picture of that, what it looks like there as well. So it looks like we have the right protocol for this. So that's really good. So now what I'm going to do is I'm just going to delete this part. And yeah, so that's how you, so that's the final part of the Arduino code. So in the next section, we'll create the code to send from the Chrome web browser to the Arduino. So we'll do that in the next section. And we'll also add some buttons to connect the Arduino to the Chrome browser. So I'll see you then. This section, we're going to send a message to the Arduino from the web browser. So let's get started. We'll start by turning on our svelte server. So npm run dev. Click on this, and we're off. Alright, so the way that all these permissions work with the browser is that you have to create a button, and the user has to click that button or click something. It doesn't necessarily have to be a button. And then that button will prompt the user to connect. So let's start off by creating that button. So I'm trying to decide. I think we'll do it. Yeah, we'll do it under here. Or no, we'll do it under the H2. That'll be better. Or under the H1. So we'll do section. No, we'll just do a button because that's all we're going to be doing. So let me do a button, and we'll call this connect. And actually, we'll do an H2. We'll do a section here as well. So we'll do a section, and we'll do, let's see, maybe an H3 status, just so they know. And this will contain like if it's connected or not. So let's just see how that looks. It's not going to look too great. So yeah, so we'll move this over here and style up the button a bit. So let's call this section connect USB connection info, just something like that. So we'll copy that, we'll go here, we'll say width 500 pixels, margin 5 pixels top and bottom, auto top. Let's see how that looks. Okay, so that looks okay. Kind of thinking maybe we'll put the button, should we put the button inside? Or, so maybe it'll look something like this. Let's see how this looks. Maybe this will look better if it's like that. I don't like that either. Try paragraph, see if that looks better. We don't need it bold. I think, yeah, that looks fine. Still can't read that. That's not very clear. So what we can do is we can say USB connection info H3 letter spacing 1 pixel. Let's see how that, it's a little bit clearer. Let's go 2 pixels. There we go. So now it's pretty clear. Status connected. Let's text align center. And we'll also, I think we can just do that for the whole thing actually, because that'll center the button too. So we'll remove that. And then let's do the button. So USB connection info button border none padding 10 pixels outline none font size, let's say 16 pixels. See how that looks. It's looking better. Cursor pointer. Okay, and then we'll do USB button active, and we'll just make this for all buttons, even though, because we don't want any outlines. So outline none. Okay, so that looks pretty good. And we'll also add a style for disabled. So we'll do button disabled, and we'll say, let's see, cursor no drop. Actually, we'll do no drop for disabled. Kind of debating, should we just make it disappear? Well, let's just do no drop. That's fine. Okay, so that looks good. And I think we're ready to create our event for the button. So that's really easy to do. You just we'll make this a little bit bigger so we can see it better. We'll do an on-click, connect USB. Now it's yellow because we haven't created the function yet. That's easy enough. So we'll say function, connect USB. And I like to test this before I go further, so I'll just say here, do a quick alert test. So when I click on it, I should get the here alert, and I do. So that looks good. And then we need to make this an async function. Okay. So before we go any further, there's one thing you're going to need to turn on. So if you go to Chrome flags, and I'll have, you can't really have a link, but I'll have this string in the video, or this piece of text in the video. But you'll need to turn on experimental web platform. So if you search for it, you'll find it, and then you'll need to click enabled. And when you do click enabled, the browser will restart. If this isn't turned on, then you won't be able to connect, basically, to Chrome Serial, because it's an experimental feature right now. Now, sometime in the future, we're not sure when, this won't be an experimental feature, but for right now it is. Okay. So we'll just do something just to make sure. So if there is no navigator serial, we will return and we'll alert turn on experimental web features to use to connect to the Arduino. There we go. If I can spell right. All right. So now we've taken care of that situation, we can start connecting. But before we go too crazy, we're going to need to create some variables just to keep track of some things. So the first thing we're going to create is our port. So I'm going to say let port, and this will represent the USB connection between the Arduino and the browser. The next one is the writer, and the writer variable will be used to connect to the Arduino and send a message from the web browser to the Arduino. So there's a writer and a reader, but we'll need that. And the other thing that we'll need is a status. And we'll start the status off as disconnected. And we'll set this to various things based on whether it's connected or not. But we'll output it right here. And we'll also make the disabled attribute of this button. So if the status does not, if the status equals connected, so that means it's connected, then we want this button to be disabled. And let's test that out by starting the status off as connected. And yep, that's looking good. And then we'll say disconnected. Okay, cool. So that's the other thing we'll check too. We'll say if the status equals connected, then we want to return. We don't want to ever try to reconnect when it's already been connected. Okay, so now that we have that, we can start using our stuff. So we're going to say port, which is our USB connection, equals await. Now because we're using await, we need to wrap this in a try and a catch. Okay, so almost forgot that. So we're going to say port await navigator.serial .request port. Now this is very important. I'm going to just show you what happens when we don't put any filters in. So this is the place where you would put the filters in. You can put in an optional argument here, but I'll show you what happens when you don't put the filters in. So I'm going to save this, and I'm also going to console.log the error as well, just so you can see the error that we'll be catching. It looks like there's an error here. Let's see what we did wrong. Oops, probably nothing major. Let's get rid of that. So it's saying FS is not defined. So sometimes Visual Studio will just import stuff. Super annoying. But that's easy to fix. So let's get rid of that. Okay, so let's see. So now I'm going to click connect. And you can see we have all this stuff. So this Bluetooth, this SoCal. So you can see we have all that, which is bad. We only want to show valid Arduino devices, or the Arduino device that we're using. So let's cancel out of that. Okay. And if I hit inspect, we'll probably see a message. Here, message. Yeah, so DOM exception, no port selected by user. So that's some of the stuff that you might see here. This isn't, I don't think there's anything you need to handle here, but it's just something to note. So if you wanted to do something, you could. Okay, so now what we need to do is we need to pass filters. And if you look at the documentation, and I'll link to the documentation, it says vendor ID, and that's wrong. Do not do vendor ID. You have to do USB vendor ID. And because I'm only using the Arduino Uno, I'm just going to put that vendor ID, but you could put whatever vendor ID you're using. So let's test that out really quick. So I'm going to click connect, and that didn't work. Let's see, I might have spelled filters wrong or something wrong, because it was there, USB vendor ID. So filters, that's right. That looks right. 2340. Let me just try this. So I'm just going to copy this in. Oops. So I'm going to copy this in. And then paste this in. It's weird. It might have to, that'd be weird if you couldn't just specify it like a regular argument. Yeah, so that works for some reason. But you can't just pass it in. So you can't just do this. Let me see. Let me see if this works. Because I might have typed something wrong. Yeah. So you can just pass it in. I probably typed something wrong. Let me see what I did wrong. Sorry. So filters. Oh, it's 3, 4. Yeah, so you have to type in the right vendor ID. Sorry. So yeah, so type in, be sure you have the right vendor ID. So that's what I did wrong. So now we just have one, and that's what you want. You don't want like the user to try to pick one. And it also, I think, makes your app more secure and trustable. So now we need to open the ports, which is going to return a promise. So that's why we're doing this here. And the baud rate, we set in the Arduino code was 115,200, which is basically the number of 0 and 1s per second that we're sending to the Arduino. And then we can set, if that all works, we can set the status. I'll just do this here to connected. So we'll test this out real quick. So we'll connect. So you got to select it, click connect, and you can see I got this little icon here. So that means I'm connected. So that's working. That's good. So I just refreshed. So I did Control R. So now what we want to do is we want to set the writer. So I'm going to say port dot writable, which is a stream, get writer. What's a type of stream? Yeah, there's a bunch of weird objects with this, but basically you want that. So you want to get the writer variable. You want to set the writer variable to this, which will allow you to send messages to the Arduino. So that looks good. So now we have the writer, and it is connected. So we can save that. And the one thing I forgot to put in, oops, and this is wrong. No, actually this is right. Let me put a note here. if it's connected, we want to return. Yeah, so we only want to execute that once. Okay, so we've got that. So let's make sure our button disables as well. Just want to make sure that I can't click this. So yeah, so it's looking good. I think the only thing we want to do is make that cursor. So let's look at this. I want to make sure that disabled is on. So let's see. It's being overridden. I think it's being overridden because this style is a little bit more specific. So we'll just make it the same level of specificness. So right there. So now hopefully when I connect, yeah, I don't see the no thing. Okay, and the status is connected. Cool. And the status changes. So now what we want to do is we want to do a pretty cool reactive statement. I think it's cool. But we also need to, before we do that reactive statement, we need to create a text encoder to encode this. What this does is it basically takes the string and turns it into an array of bytes so that the Arduino can digest it. So I've seen it called ENC. Let's just call it text encoder so we know what it is. I don't know what ENC means. Sorry, I can't type today. There we go. So that looks good. Okay, so we'll need that object later. And now what we want to do is we want to create that reactive statement. So we'll do that right here. So we'll say $:, and we'll do an if. We'll say if the status equals connected, and I was thinking I'm in Python. I was about to type and so if the status equals connected and the LEDs, what is that called? What are we calling it? Putting there, Arduino message. Does not equal that, then we'll go ahead and send it. So if either of these variables change, this will re-execute. So now we can say writer dot write, and then we say text encoder, because that's what we called it, dot encode Arduino message. Okay, so in real time, every time we want to send a string or anytime this string changes, this should now execute, this line 46. So I'm going to test that out. All right, so everything's working now. So I wanted to get my video camera going so that you could see it happening live on two screens. So you can see as I click the buttons, everything appears, so I can see the message changes and everything else changes, which is pretty cool. So now I can just kind of draw little fun things. So one thing that would be cool to add is a clear button, which wouldn't be that bad. I mean, right now you can refresh and reconnect, but you can see, yeah, so you can draw a little fun. So let me refresh, reconnect. Now, one thing that I found that was pretty fun you could do is a little boat. So I'll do that. Show you what a boat looks like. So that's a little boat. So yeah, so I thought that would be, this was a fun little tutorial on using an LED matrix with the website. It's pretty cool that you can do this now. So big shout out to the Google Chrome people for for allowing this. And yeah, I think as a good challenge would be just to add like a reset button. So you might want to see if you can do that. But let me know what you guys think, and I will catch you guys later.